Now that you understand the process for multiplying rational functions, I'm going to show you how to divide rational functions. The nice thing is dividing is super, super similar to multiplying. So if you think back to when you learned how to divide with fractions that had numbers on top and bottom as opposed to polynomials on top and bottom, look at what we did. So if I, for example, had 2/3 divided by 1/2, hopefully you all remember that I would rewrite the first fraction, change divide to multiply, and take the reciprocal of the second fraction. What is a reciprocal? It's a flip of what you have. So flipping the second one, I have 2/1. Once it's a multiplication problem, I just follow my multiply rules. I check there's nothing that I can reduce in terms of what's on top and what's on bottom. So I'm going to go ahead and skip that reducing or that canceling step. Multiplying straight across, I get 4/3 for my final answer. Guess what? We're going to do the exact same thing when we look at rational functions. So here are my instructions. I'm going to leave my first fraction alone. I'm going to change divide to multiply. Flip the second fraction. From there, I'll follow those steps that I had for multiplication where I factor, I reduce, and I state my domain. So let's look at the first example. So first thing I'm going to do is I'm going to rewrite the first fraction, which is 3 minus y over 2x minus 1 times x plus 5. I'm going to change that division to multiplication, and I'm going to take the reciprocal or flip the second fraction. So 2x minus 1 times x minus y is now on top. 6 times y minus 3 is now on the bottom. So now I'm going to check my multiplication rules. Well, if I pull out my notes from multiplying, I see the next thing I want to do is factor. Well, look it. I've already factored. This step has already been done for me in this problem. So since the factoring has already been done, the next thing I'm going to do is I'm going to go ahead and reduce. I'm going to reduce 2x minus 1 with 2x minus 1. I see that that's all I can reduce as written, but I'm going to notice that 3 minus y has a positive 3 and a negative y. Y minus 3 has a positive y and a negative 3. So they are exact opposites. So I'm going to go ahead, even though the factoring is done for me, I see that doing an additional factoring step is going to help me out in the long run. So I'm going to go ahead and I'm going to factor a negative 1 out of here. That is then going to give me a negative times negative 3 plus y and x minus y on top, just going ahead and doing that multiplication on the top, and x plus 5 times 6 times y minus 3 on the bottom. And now I notice that even though they're written in different order, it doesn't matter what order I add or subtract in. So a negative 3 and a positive y and a negative 3, I can go ahead and also cancel those out, giving me a final answer in simplest form of negative x minus y. If I wanted to, I could distribute that in. I'm going to go ahead and since it doesn't matter what order I multiply, I'm going to put the 6 in front of the x plus 5. And all I have left to do is now state my domain. So in order to state my domain, I'm going to go back here before I canceled, and I'm going to set each factor equal to 0. Doing that, I get when does 2x minus 1 equal 0? When does x plus 5 equal 0? 6 is never going to be 0, so I'm going to go ahead and skip setting 6 equal to 0. And when does y minus 3 equal 0? Well, solving 2x minus 1 for x, I would add the 1, then divide by 2, and I get x equals 1/2. Solving x plus 5 equals 0, I would subtract 5. And solving y minus 3 equals 0, I would add 3. So I do get a domain of x cannot equal 1/2, x cannot equal negative 5, and y cannot equal 3. So there is my simplified form in the answer, or my simplified form, as well as my domain. So all real numbers except for those 3 restrictions. Looking at the second and final example. This would be, I know there's only 2 examples on this, but this would be a great one for you to try before watching me go through it, because there are only 2 examples and you have had some experience with multiplying, and since division is so similar, you should be okay. Okay, so now going through my steps, first thing I'm going to do is I'm going to rewrite my first fraction. Change divide to multiply and flip my second fraction. Now that it's multiplying, I'm going to go through my multiplication rules. And my first step in multiplying is to factor. So I'm going to go ahead and I look at the top here. I see I have a trinomial that does not have a coefficient on my quadratic term. So I'm going to go ahead and say factors of negative 15 with a sum of 2. Well, I know that 5 times negative 3 is negative 15, and 5 plus negative 3 does equal 2. So I'm going to factor that to be a plus 5 times a minus 3. On the denominator, I see a squared minus 16 is perfect square minus perfect square, and I know a squared minus b squared equals a plus b, a minus b. So for that first fraction, I see that my a is a and my b is 4. So that will factor to be a plus 4 times a minus 4 times, I can take a GCF of 3 out of my numerator, giving me 3 times a minus 4. All over a plus 1. Now that I've factored, I'm going to go ahead and check to see if anything cancels. And I see an a minus 4 and an a minus 4 cancel. And that looks like that's all that cancels. So then writing in my simplest form, I'm going to go ahead and move this 3 to the front since it doesn't matter what order I multiply in. 3 times a plus 5 times a minus 3 all over a plus 4 times a plus 1. And I do have to put this in parentheses to show that I'm multiplying this whole bottom by this whole bottom. Finding my denominator then, I'm going to go ahead and go back to before I canceled and set each piece equal to 0. So when does a plus 4 equal 0? When does a minus 4 equal 0? And when does the factor a plus 1 equal 0? Solving this first equation, I get a equals negative 4. Solving the second one, I get a equals 4. And solving the third, I get a equals negative 1. So my domain is a cannot equal negative 4, a cannot equal 4, and finally a cannot equal negative 1. And there is my answer in its simplified form, simplest form, as well as my domain.